G'day folks, I just wanted to put together a video on exercise 3C from the Cambridge Year 12 Standard 2 textbook. That exercise is on inflation and appreciation. So what's inflation? Inflation is when the cost of something goes up. Okay. Normally, without getting into the politics or the morality of it, as a general rule, what you buy something for in time can have an increase in price. It might be because it's rare, okay? So you might buy yourself a really nice vintage car, for example. You might pay $50,000 for it this year, and in 10 years' time it actually would have gone up in price because it's become even more rare, for example. So that's an example of what we call appreciation. That's not so much inflation, that's appreciation. You might go to the supermarket and buy a box of cereal. Today it might cost a certain amount, and in 2 years' time it might be more. Okay, that's what we call inflation. Now, appreciation and inflation, where the cost of something goes up over time, mathematically they're exactly identical to compound interest. Okay, so it's exactly the same formula. They even use exactly the same symbols in the formula. For example, we talk about the future value. So what will it be? After a certain period of inflation, what will the cost of this thing be? In other words, what is its value in the future? So it's exactly the same as compound interest, no difference, right? Equals the present value outside of 1 plus r to the power of n. Now the same rules, exactly the same rules apply. So r and n have to agree. We saw that when we looked at compound interest for starters. Okay. PV is the present value. What does it cost today, in today's money, if you like, in today's dollars? What is the value now? Future value, what will the value be after this number of periods has gone on? All they can do now, the only thing that the only way they can sort of try to dress this topic up or make it seem like it's harder or more complex or more involved is just by changing some of the wording. So instead of saying Bob invests $5,000 at this percent, compounding, quarterly for this many years, they now say Bob buys a vintage car for $20,000. It appreciates at a rate of 6% per annum. What will Bob's car be worth in 10 years? Okay, so they're just changing the language of the question. Sorry about that little interruption. They're just changing the language of the question, but the mathematics is exactly the same. So let's have a look, okay? So let's do that question I just spoke about with Bob buying his vintage car. So he buys the vintage car. In today's money, he pays $20,000 for the car. He gets a good deal. Okay. It appreciates at the rate of 9% per annum, and he owns the car. He hangs onto the car for 15 years. Now look, you might get an appreciation question where they're talking about, a number of months, for example. It's unusual. They tend to leave those, something grows or compounds at 9% per annum, and the interest compounds quarterly or monthly. What's it going to be worth after this many years? But as a general rule for inflation or appreciation questions, they're going to talk in rates per annum, and they're going to talk about a number of years. Okay, because it's it's not like in a month it's going to go up by a fixed amount of money. So as a general rule, you're not going to have to do that fiddling around where you're changing, percent per annum into percent per quarter or percent per month or anything like that. Or changing 15 years into months or quarters or things like that. So we're just going to leave it like that, because most of the appreciation questions we're going to get are going to be like this anyway. So we know that our future value is our present value outside of 1 plus r to the power of n. So in other words, we've got 20,000 times 1 plus, now remember, our interest rate cannot be a percentage, it must be a fraction or a decimal. 9 over 100 to the power of n, which is 15. We grab our calculator. We put our glasses on. Now, no one's going to pay $72,849.65 for a car. So almost always you're going to find these questions are asking you to round off to the nearest 100 or to the nearest 1,000 even. Okay. So let's round this one off to the nearest 100. So what number is in the hundreds column? Well, if we read the number out, okay, so if we actually speak it out and listen to what comes out of our mouth, $72,849.65. So that 8 there, that's the figure that we want to round off to. So we look at the digit after that. Now, because that digit is 4 or lower, then we round off by just cutting off the 49. Okay, so that's going to be $72,800 to the nearest $100. If you still struggle with some of that rounding off or significant figure type work, make sure you ask me about it so I can do a little refresher video, or maybe even cover it for the first time for some of you. Either way, guys, have a go at exercise 3C in the textbook. It starts off pretty simply. In fact, I think the first question even starts off with a vintage car question. Have a go. I'd like you to do more than just the first 3 or 4 questions. See if you can get at least down to question 7 or 8. Shooting me questions as you go. If there's any problems at all, as usual, questions in the comments below. Flick me an email or put a message through on our Microsoft Teams group. Thanks very much, guys, and keep on working hard.